Hello, in this video we were going to be looking at measures of central tendency. Which will include a discussion of mean, median, and mode. So the reason that we look for measures of central tendency is they allow us to summarize data and to answer the question, what is typical, common, normal, or average? So let's start with a little bit of review, just as a reminder of the distinction between a sample and a population. In a research study, we're often interested in characteristics of an entire population, the full group of objects or individuals, but oftentimes in the practice of statistics, we do not have access to the entire population, and we rely on samples. When we summarize the information from a sample, we call that a statistic. And when we summarize the information from a population, we call that a parameter. And we often use a different symbol to distinguish between a statistic and a parameter. For instance, if we're talking about the size of a sample, we might use the letter n. So for instance, I could say n equals 20 means that the sample size is 20. Whereas for a population, if I know the size of the population, I would use a capital N, and I might say n equals 330 million. If I were referring to the population maybe of the United States. I bring that up because one of the first measures of central tendency that I'll discuss is the mean. So the mean is, in everyday speak, often called, just referred to as an average. And the symbols that we use for mean are x bar, that's for a sample, and the Greek letter mu. So that's pronounced mu. Both of these symbols indicate the mean, but x bar indicates the mean for a sample and is a statistic, whereas mu indicates the mean for an entire population and is therefore a parameter. The way that we calculate the mean, how you would calculate an average, is adding up all our values and dividing by how many we have. I don't want you to get too bogged down in formulas or notation, but I will mention that if you look in your a statistics textbook for the formula for the mean, when we're referring to the sample mean, you might see something like this, where this is the Greek letter sigma and indicates summation. The x represents our variable, and the subscript of I is an index, and all this means is to add up all the values of your variable and then divide by how many you have. Again, I'm using a lowercase n because this is the sample mean, and the lowercase n is the sample size. Now, for the population mean, I'll use the symbol mu. I would still add up all the values of my variable and then divide by how many I have, but in this case I would use the capital N because that would be my population size. So next, let's look at the median. The median is the value that lies in the middle of the data when arranged in ascending order. So let me just put a small data set here on, let's see, 29, 35, 47, 53, 60, 64, 69, 71, 80, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going to just stop there for now. Let's say that these are scores for a certain homework assignment. So the median is the value that lies in the middle. So for a small data set, I might be able to look at the smallest value and the largest value, and then systematically keep moving in by one from each direction until I close in on the value that's in the middle. So notice that there are 4 values to the left of this middle value, and that there are 4 values to the right. So this number is the median, and we use a capital M for median. Now, what if I were to use these same values but add one more, maybe 88. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I use the same strategy of counting towards the middle from both ends, so 1, 2, 3, 4, 5, I have 5 in the top half and 5 in the bottom half, but there's no value that's left in the middle because I had an even number, so they divide evenly into 2 groups. In this case, I'll take the average of these 2 values. So I'll average 60 and 64 in this case by adding and dividing by 2. So this would be 124 over 2, which is 62. So the median for this data set is 62. However, for a large data set, you're probably not going to want to, list your data in order and then count with your fingers towards the middle. So I'll put finding the median for a large data set. So this is just a step-by-step process. The first thing you want it to do is order the data. And again, this would be least to greatest. And then index the data. All that means is number the values from 1 to n. So n would be your sample size, so from 1 to however many you have. And third, we're going to locate the median by, the strategy is a little bit different. If we have, for an odd n, we'll take n plus 1 over 2 and look in this position for the median. So going back to the example I had here, so where I have, this is when I have an odd n, so that was the case here. So these are already in order. This would be the first value, second, third, fourth, fifth, sixth, seventh, eighth, and 9. So I have 9 items. They're in order. This is what I mean by indexing, just numbering them. So if I take n plus 1 over 2, n plus 1 over 2 would be 10 over 2, which would be 5. So I'll look in position 5. And so 5 is not the median, that's just where I look for the median. The actual median is still 60. For an even sample size, I can take n over 2 and n over 2 plus 1. So, for instance, here I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would number these 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. N over 2 is 5, and n over 2 plus 1 would be 6. So I'll average those two values. Average the values in these positions. So I'm going to stop there. In the next video, I'll pick it up and we'll compare mean and median, and we'll talk about the third measure of center, which is the mode.